Okay, guys. Okay, so let's get started with the session, guys, without any further ado. So again, do not end the session. I guess a couple of the other people also have my same name. So you also have the permission to end the session, guys. So do not end it or anything. Okay. I'll be changing the link tomorrow. I could not get the time to update this link today. So I'll just change it tomorrow and send you the new link for all the people who have sent previously. Okay. Now, one last time confirmation. I hope you can hear me properly, and I hope the screen is visible as well.
Yeah.
Right. So in the last class, we discussed up to the IDV for address ranges, the different classes, and the different private ranges. And now the main question arises is, why do we have these different classes? What is the relevance of them, and why is the differentiation? So the main difference is the number of network portions and the host portions. In class A, there is one network portion and 3 host portions. In class B, there are 2 network portions and 2 host portions. In class C, there's 3 network portions and 1 host portion. And finally, in class D and class E, there are no host portions at all. There's only network portions. Okay. So now, what is this network portion and what is this host portion, and why are they relevant? Okay. So as you can see, as we progress down the line, the network portions are increasing and the host portions seem to be decreasing. Okay. So we'll take the first example of class C. Okay, where it only has one single host portion. Okay. So in class C, the first private IP is 192.168.0.0. So I've written down the same thing over here, 192.168.0.0. Okay. And in this, the first 3 octets are the network portions, and the last octet is the host portion. Now, after 0.0, the next IP is 0.1, then 0.2, then 0.3, 0.4, 0.5. Like that, it goes on up to 0.255. Now, once it reaches the maximum value over here, this 255 resets back to 0, and the 0 now changes to 1. Okay. Then you have 10, 11, 12, 13, 14 up to 1255. Then you have 20. Okay. Now, what I mean by this network and host portions is that as long as the network portions are same, all these IPs belong to one singular network. Okay. And they're just different hosts, okay, individual devices in the same network. But as soon as a network portion divides over there, so when it changes from 0 to 1, whenever the network portion value changes, the network divides over here. Okay. So now these devices belong to a complete separate network from any other devices in other networks. Okay. And they can't communicate with one another unless and until there is a router in between. Okay. So this is one singular network. This is another network, like that. There's another network over here from 2.0 to 2.3255. Then from 3.0 to 3.255, that's another network, like that. Wherever the network portion changes, the network divides. Okay. Now, when we take class B example, there are 2 network portions and 2 host portions. Okay. I've written down the first IP in the class B range, 172.16.0.0. So after that, you have 0.1, 0.2, 0.3, 0.4 up to 0.255. After that, 1.0, 1.1, 1.2, 1.3 up to 1.255. Like that, the cycle repeats again and again and again up to 255, 255. Now, once both these octets reach the maximum value, this 16 now changes to 17. Okay. Again, as long as the host portion change, doesn't matter. They're just different devices in the same network. But as soon as the network portion changes, once the value changes from 16 to 17, network completely changes. Okay. So the network divides over there. Okay. Now, all these devices belong to one network. And then after that, all these devices belong to a separate network. And like that, in class B now, we can connect a total of 255 into 255 devices. So in class C, we could only connect from 0.0 to 0.255, which is like 255 devices in total. But in class B, you can connect 255 into 255. So you can connect around 65,525 devices. Now, logically, sounds very different, but practically, you might not be able to connect those many devices in a one singular network. It would create your network it would create a huge amount of bandwidth in your network and slow down the network and shut it down slowly, eventually. Okay. Now, but logically speaking, it gives you the chance to connect more than 255 devices. Now, when we come to class A, finally, class A has only one network portion and 3 host portions. So from 10.0.0.0 all the way up to 10.255, 255, 255, all these are one single network. Okay. Now, as soon as this 10 changes to 11, so whenever the network portion value changes, the network divides over there. So in class A, now you can connect 255 into 255 into 255 devices in each single network. Okay, so like that, from this we understand where in class C, where we could only connect 255 devices, this can be used for small networks like your home network or your small offices and so on. If you wanted to use much more devices, more than 255 in each single network, such as like in multinational companies or so, there you can use class B and class A. Okay, class D and class E have no private IPs. There's a specially assigned IPs for research and development, military organizations, government portals, and broadcasting and telecasting services. They are not given to the general public. They have their own special purposes. Okay, so is this clear, guys? Why we have different classes and what is the relevance of each of these classes? Did I explain this already in last class, or this is the first time? Ishwarya or
First time, right?
first time, right?
Yeah. Yeah. For me also first time. So this class A, B, C, D, right? So is this like, costly environment to use one versus other? Because something, why we have this kind of restriction, right? So if something is used for multinational companies, so is there something?
It's not cost. No. It's not cost or performance related at all. All IPs function at the same performance. There's no price. All of them are private IPs are completely free. No one can put a price on them or anything. Okay. The only difference is that how many devices you can connect in each network. In class C, you can connect only 255 devices in each network.
Okay.
In class B, you can connect 255 into 255, like 65,000 devices. In class A, that's even more, 255 into 255 into 255.
So if everyone is using class A, so will there be any performance related?
No such thing. No such thing at all. Not at all.
Okay.
So it doesn't make any difference whether you use class A, class B, or class C at all. Okay, so there will be no issue with the performance or nothing. Okay. So it's just that if you have very few devices,
if there is a company using class B and if their employees or machines are increased, then they have to shift to use class A, right? So if it is not sufficient.
That's it. Okay.
Yeah.
In a real-time scenario, Ishwarya, practically speak, in any network, in any organization, you won't use more than 255 devices in each single network. Okay. You can have multiple different departments again. But in each department, you would rarely ever have more than 255 devices. So if you do have, you go with class B. Okay. Now in class B, you have 65,000 devices that you can connect in each single network. So you would need multiple switches like that to have ports, 65,000 ports like that. Okay. So rarest of the rarest possibilities you'll ever have a network about 255 devices. Okay. So but still, logically speaking, class B and class C give you the possibility of connecting more than 255. Okay, right.
Yeah.
Now, again, I see some new faces over here, or new students. Anuj, have you attended yesterday? Anuj and there's Jagdish. I guess you two are new to today's session. Is this your first session, guys?
Yes.
Hi, Jagdish.
Yesterday I didn't.
No worries, Jagdish.
Yesterday I didn't attend it.
Oh, you attended or you did not? Your voice is getting cut. I can't hear you properly.
I think I window issue. Am I audible now?
Okay, I'm assuming you did not attend. Okay. So again, no worries, guys. Just in case if anyone is completely new to this and if you have not attended the session yesterday, just a quick recap. What we discussed yesterday was basically what IPv4 addresses are and how do you convert, or what is the range of IPv4 addresses. Okay. So we learned that IPv4 addresses start from 0000 and go all the way up to 255, 255, 255, 255. Now, between this range, again, there are different classifications. Okay, so there's multiple classes in between. Okay, and in each class, you have something called as public and private IPs. Okay, so we discussed what these public IPs are, what these private IPs are. Okay, and why we have these different classes in today's class. Okay, that's a very quick recap. Okay, so just in case if you have missed out, you can access the recording. You will be sent the recording once you make the payment. Okay, so you can go through the previous recordings from Monday. By Monday, all the payments will be done. So from Monday onwards, we'll be sharing all the recordings, guys. Not an issue. Okay. Now, after we are done with this classes, let's go with the next concept of subnet mask. Okay. So basically, when you open up your command prompt, if you just open up CMD and if you type for IP config, this shows you your private IP. I've shown this in last class also. So as you notice over here, this IPv4 address, this is my private IP. Okay, and just below IPv4 address, we see something called subnet mask. Okay, now what is the subnet mask value? Okay, so for us humans, we easily understand which class belongs to, which IP belongs to which class from the network and host portions. Okay, so we know class A has 1 network portion and 3 host portions. Class B has 2 network portions and 2 host portions. Class C has 3 network portions and 1 host portion. But how would a computer know that which class contains how many network and how many host portions? So for that, they have a value called subnet mask. In subnet mask, what they do is they assign the network portion with the value 1. Okay, and the host portions with the value 0. Okay, so the computer knows from the subnet mask. So if there is only all ones in the first portion and all zeros in the rest of the portions, the subnet mask value is 255,000. And from that, it figures out, okay, that IP is a class A IP. Okay, in class B, there are 2 network portions and 2 host portions. So all ones in the first 2 portions, all zeros in the last 2 portions. So when I convert this from binary to decimal, you get 255,255,000. And that is the subnet mask for class B. Finally, for class C, there are 3 network portions. So all ones in the first 3 portions, all zeros in the last portion. And that would be 255,255,255,000. Okay. Along with the subnet mask, in Windows, you primarily use subnet mask. In Linux operating systems, sometimes you use something called CIDR. Okay. CIDR stands for classless interdomain routing. It's an alternative for subnet mask. So CIDR value is nothing but the number of 1 digits you have in the whole subnet mask. So in class A, there's 1 network portion, which has 8 consecutive ones. So that is why CIDR is /8 for it. Okay, so class A, if you mention /8, computer understands, okay, this is a class A IP. If you give /16, so if you have 16 ones, it means that it belongs to class B. Okay, and if you give /24, it means that it belongs to class C because it has 24 ones consecutively. Okay, so these are the default subnet masks and the CIDR values for IP addresses. Okay, just for the computer to understand or for the network admin to understand which class of IPs they're using in their organization. Okay, so if you notice over here, I get the IP 192.168.1.6. Okay, and this IP, which class does it belong to, guys? Out of the private IPs. So if this is the range over here.
Class B private IPs.
B, are you sure?
No.
192.168.1.6 over here. So these are the 3 ranges.
Yes.
Class C, right?
A class A private IPs.
Sure, guys. Okay, someone has said C, someone has said A. How many of you agree with C and A? Oh, here is the IP address, as you can see. And these are the ranges for all the private IPs. How many of you say C and how many of you say A? Okay, Madhusudan has said C. Ishwaraya has also said C.
Yes.
Yeah. So again, guys, carefully observe 192.168.1.6. And that is falling between this range, 192.168.0.0 to 192.168.255.255. So therefore, that is a class C private IP. If you remember, in last class also, I gave one of those IPs over here, 192.168.1.5. And you yourself answered it that it belongs to class C private IPs. Okay. So again, please do not forget these ranges, guys. Very important. Okay. Once you know the ranges thoroughly, as soon as you look at an IP, you know which class it belongs to and whether it's a public or a private IP. So now this IP that I'm getting over here, can anyone tell me whether this is public or private? Hello.
Which one?
This one that I see in the command from 192.168.1.6.
Okay.
Private.
Private, exactly.
Private.
And, so,
Yeah.
and you have told that this is class C private. And if you notice for class C, the subnet mask is 255.255.255.0. And that's the same thing that I see over here, just below it. Okay. So that confirms it that this IP belongs to class C for us. Okay. Now, coming to the next concept. So after this, you see something called as default gateway. Default gateway is nothing but the router, guys. A router always gets the first IP in the network. Ignore this IP. This is IPv6 for the time being. Okay. This is the IPv4 address. So my device is like I1.6 and router is like 1.1, the first IP. 1.0, you will never use the 0th IP and the 5th IP. 0th IP is known as the network ID. 255th IP is known as the broadcast ID. So you always ignore those two IP addresses and you always start from the first IP, 1.1. And the first IP by default is always given to the default gateway, which is nothing but my router. Okay, so right now I'm using my Airtel connection. So if I go to my browser and if I give my router IP 192.168.1.1, you'll notice it opens the router login page from. Okay, so router is always the first IP in the network. Okay, so if you're using a D-Link router or TP-Link router in your network, whatever IP you get over here, if you copy and paste that in the browser, you get the login page for that router, through which you can modify the settings for the router. Okay, now coming with the next concept, how do we change our private IP? So we know that public IPs are given by ISP. We have no say in that. They can assign any IP of their choice, but private IPs are in our own hand. Okay, we can be the network admin for our own network and we can change the IP according to our wish. Okay, so there are two methods of getting an IP address for your system. Okay, one method is an automatic method. So you won't be doing anything. You'll just configure a DHCP server and that DHCP server will automatically give your device an IP address. Second method is manual method. So you can assign an IP to your system yourself. Okay, so let's go with the manual method first, how you can change the IP for your machine. And then we go with the automatic method. Okay, so if you want to change the IP address for your machine, right now I'm getting something like 192.168.1.6. Okay, so if I want to change that, I'll just open up my control panel. Okay, and in the control panel, I'll go to the network and internet settings. So I'll go to network and internet. In network and internet, I'll go to network and sharing center. And in this, I'll go to the change adapter settings. Okay, and this shows me all the adapters that I have on my device, the Wi-Fi adapter, the Ethernet adapter, the virtual adapters for my VMware, and so on. So whichever IP you want to change, whichever adapters IP you want to change, you right click on that. Okay, so there's a shortcut also, guys. Rather than going through this long path, if you remember a simple word in Windows R, you get the run. And in run, if you type ncpa.cpl, okay, this also gives you the same page. Okay, I have also written it down over here in the notepad file. Okay, in run, you will search for ncpa.cpl. Okay, or if you want long path, this is the complete long path: control panel, network and internet, network and sharing, change adapter settings. Okay, now once you know which adapter you want to change the IP for, right click on that, go to properties. In properties, select the IP version 4, Internet Protocol version 4, and click on properties again. And now you can see there are two options. Option number 1, obtain an IP address automatically, which means you're getting an IP address right now from a DHCP server. Now, what is this DHCP server? Don't worry, I'll explain that in a few minutes. Okay, but if you want to assign an IP address manually, if you want to give your own IP address, select the second option. Okay, now all these fields open up. And now give your own IP of your choice. So I can give 192.168.1. Earlier I was getting something like 6. Okay. Now let's say I want to change this to 100. Okay. So I'll type 1.100. Now once I click on Subnet Mask, automatically you can see it gives 255.255.255.0 because this is a class C address. If I give a class B address, so let's say if I just change this from 192 to let's say 172, 172.16.0.10 or something. So I just gave a random class B address, guys. And now when I click on Subnet Mask, carefully observe. Now it says 255.255.00 because this is class B. If I give a class A address, can anyone tell me a class A private address? What could be a class A private address? You can refer to the notes I have over here. No worries. Can anyone tell me a class A private IP? Yeah, correct answer, Ravi. So you can give 10 dot something, okay? Because in class A, it starts from 10 dot network over here. So I can just give something like 10.0.0.10 or something, any random number, okay? And if I click on Subnet Mask again, you see now it says 255.0.0.0, okay? So 255, it means that only the first one part is the network portion. The remaining all are the host portions, okay? So I'll just come back and give my class C address only 192.168.1. Let's say 100. Okay, Subnet Mask is automatically selected. Default gateway, the first IP in the network, which is 192. Oh, sorry, 192.168.1.1. Right, also asks you to enter a DNS server IP. We have not discussed what DNS server is until now. We'll discuss this shortly in a minute. Okay, but if you don't know what to enter over here, go to the browser and search for Google DNS server IP, and this will give you two IP addresses. Google DNS server IP. Okay, and this will provide you two IP addresses. One is 8.8.8.8 and the other is 8.8.4.4. You can use any one of them. Okay, so just in case if you don't know what to use, just go browse on the internet and just give that IP 8.8.4.4, let's say. And now when I click on OK, let's carefully observe as 192.168.1.6. But if I run the same command again, ipconfig, now you will notice my IP address will be changed to 1.100. So this is how you can manually assign an IP address to your system. Hello, guys, can you hear me?
Yeah.
Okay, so whenever I change the IP address, there might be minor network issues because the connection will get reset again. So don't worry. Okay, as you can see, I got my new IP 1.100. If I want my original IP back, if I want my automatic IP back, all I have to do is go to control panel, go to properties, go to IPv4 and click on obtain an IP address automatically. That's it. And now if I check my IP again, ipconfig, you will notice I got my 1.6 IP again. Okay, but how am I getting this IP 1.6? How am I automatically getting assigned that IP? What is happening in the background? What is this DHCP server? Let's try to understand that. So DHCP stands for Dynamic Host Configuration Protocol. This protocol came into use when people were starting to get lazy on assigning IP addresses. So network admins thought, okay, man, assigning, so if it's 2 or 3 or 10 devices, and if you have to assign IP like this manually, it's okay. It's not a big deal. But what if you have to assign in a big multinational company? Let's say each network had 250 devices or so, and the network admin had to assign a new IP every day. So that would have been a very hectic task. That is why someone came up with a process called DHCP server. Okay, so DHCP stands for Dynamic Host Configuration Protocol. The main purpose of it lies in the meaning of its name itself. Okay, so dynamically host configuration protocol is nothing but automatically or dynamically configuring an IP address to each and every host. So whenever you connect a device in a network where there's a DHCP server, that DHCP server will automatically assign an IP address to it. And that IP address assignment is done with the process called DORA process. Okay, now what is this DORA process? So let me draw this out first. So let's say I have a new device in my network. Okay, so let's say this is my home network and this is my new laptop which I've connected. Okay, or PC. And there are other multiple devices which are already working also. Let's say, and let's say I have my router over here. Okay, so let's say this is my home router, my Wi-Fi router. Let me just put it over here. It's closer. Okay, now router to my Wi-Fi router, multiple devices are connected at the same time. Okay, and these devices could be getting their own IP addresses. So let's say this device is something like 192.168.1.5, and this is something like 192.168.1.4 or something. Okay, now your router always has, again, your router itself is acting as a DHCP server also, and a DHCP server will always have a pool of IP addresses, pool of free IPs. Okay, so from this pool of IP addresses only, it will assign each and every IP to a new device, whichever gets connected. Okay, and that assignment is done via DORA process. So in my pool, whenever an IP is used up, that IP gets removed. So 1.5 and 1.4 are used. So it will start from 192.168.1.2. Okay, so this DHCP server also needs an IP. So that will get the first IP, something like 192.168.1.1, let's say. Okay, so from 1.2, it'll go up to 192.168.1.254. Okay, and in between 5 and 4 are used up, so those won't be existing in the pool. Okay, now when I connect a new device, so let's say I brought a new device in my network and I connect it to the router. Okay, now the first thing what happens is my device starts sending some information out. So it starts sending packets to each and every device in the network. Okay, and these packets are known as the discover packet. So it sends it to this device, it sends it to this device, and simultaneously it also sends it to the DHCP server. Okay, And this packet is known as the discover packet. What I mean by discover packet is that it is asking, hi, are you the DHCP server? Are you the DHCP server? Are you the DHCP server? When it reaches the wrong devices, those devices will just drop this packet. So they drop it out. This also drops the packet out. Okay. But when it reaches the correct DHCP server, the DHCP server responds back saying that, hi, I am the DHCP server. You are looking for me only. What I understand that you're looking for an IP address and I can offer you an IP. So it will send an offer saying, hi, I have an offer. I can give you this IP 192.168.1.6. Okay. Do you want it? Okay. Now in return, again, my device will say, hi, thank you for giving me that IP. I want that IP. Please, I'm requesting you that you assign that IP to me. So in later on, it again sends a request saying that, hi, thank you. I'm requesting you to remove it from your pool of IP so that you don't assign it to someone else and offer me that IP address. Finally, again, this DORA process, I mean, the DHCP server sends an offer. Okay. Oh, acknowledgement, sorry, not offer, acknowledgement. Acknowledgement is like confirmation saying that, hi, thank you for requesting. I've confirmed and I've sent you this IP address to you. And this whole process is known as the DORA process. D for discover, O for offer, R for request, and A for acknowledgement. Your new client or your new device sends a discover packet to search for DHCP. Okay. In return, the DHCP offers an IP address. Again, your client requests it to allot it for it. And then DHCP finally sends a confirmation saying that it has been allotted to you. Okay. And all of this happens in a short span of a few seconds. So you won't even observe this happening. Okay. So it happens very quickly. And I'm pretty sure at least once you might have seen this somewhere. Okay. So if you connect a new phone to your new Wi-Fi router or to a new Wi-Fi connection in some new place, for a short duration after you enter the password, it shows obtaining IP address. Has anyone ever observed that in their phone? It usually occurs in phones only. It doesn't show in laptops or so. So whenever you enter a new, whenever you connect to a new Wi-Fi router and you enter the password correctly, for a short duration, it will say obtaining IP. That is nothing but in that duration, the DORA process is happening. So once the password is entered correctly, once you've connected to the router and your device start communicating. Okay. And your router, which is also acting as a DHCP server, sends the IP address to the device using the DORA process. And that is how you get the IP automatically. Okay. So is this clear, guys? Any questions or doubts up to this part? Anyone who has not understood the DORA process?
Sir, default gateway can be changed, sir.
Yeah, you can definitely change the IP address with the default gateway, not an issue at all. But usually, as I've mentioned, the basic networking rule is that, an ethical rule is that you always give it the first IP. If not first, at least give it the last IP so that everyone knows what to connect to.
And process will be same in the like Windows, Linux, and like
any operating system. DHCP protocol will work the same way. So you have the same DORA process, whether it is a Windows operating system, a Linux operating system, a Mac operating system, or even Android OS, Android operating system for mobile phones. Okay. Any other questions, guys? Anyone else? Again, if you want to check these DHCP settings and also, if you remember, I told you DHCP has a pool of free IP addresses. So if you want to check this pool, since my router itself at my home, my Wi-Fi router only acts as the DHCP server. So if I go to my router page, guys, can I clear the drawings? Can I delete these drawings now? If anyone wants to take any screenshot or so, please take a screenshot. Okay, because I usually don't save the drawings. I keep drawing every single day. So if anyone wants to take a screenshot, please take already, because I'm going to be deleting this. Okay. Now, as I've mentioned, your router itself is acting as a DHCP server. So let me log into my router and show you the setting page. So for every different router, it might be a bit different, okay, depending on the vendor. So for DP-Link, D-Link, it might be a bit different as well. Okay. But for my Airtel router, oh, 1 second. What was the password again? I changed the password recently. Yeah. So if you notice over here, my system, if I go to LAN settings, network, and DHCP. Yeah, as you can see over here. So in my, this is my DHCP server enabled. Okay, so my router itself is acting as the DHCP, and you can notice I've given the pool. Okay, so this router itself is getting the first IP 192.168.1.1. If you want to change that, you can change it from here. You can give a different IP also. Ishal, this is what you are asking about. Okay, so I can give any other IP if I want to. Okay, excluding that IP. Yeah.
Sir, most of the routers will get the same IP now, sir, 192.168.1.1.
Okay.
Why they are giving the same IP, sir?
Why not give the same IP is my question. What would happen if you give the same IP in different networks?
No, we have to. Why they follow the rule 192.168?
Because 192.168 is a class C IP. In your home networks and all, you don't connect more than 250 devices. So since it's a small network, that is why you're going with class C. And in class C, IP always starts from 192.168. That is why you get that IP.
Okay.
Okay, right. Now after this, so 1.1 has been assigned to the router. So after 1.1, from 1.2 till 1.254, this is the pool of IP addresses. Okay, from that pool only automatically whichever device is newly connected, and each and every single IP gets connected to that device. Okay, so and that is what DHCP server is. Coming to the next part, after DHCP server, we saw something else also called DNS server. Now, what is this DNS server? Okay, so DNS stands for domain name service. If I had to explain this very simply in a form of an example, this is like a contact book application for your websites. Okay, so in your phone, you have a contacts application where you link each contact name to the phone number. Okay, we humans are terrible at remembering long numbers. So that is why for each number, we have a contact name assigned to it. And whenever we want to dial up a number or search for a contact, we search it with the contact name. Okay, and we dial it with the contact name. Now your SIM card does not know or does not link what that contact name is. Okay, so it is only concerned. So when you're calling from one SIM to the other SIM, that SIM cards don't know what the contact name is on your phone. Okay, they are only concerned with that 10-digit number. Okay, and using that 10-digit number only, they redirect from one SIM card to the other SIM card. The call is forwarded. Similarly, when you're accessing a website in the browser, so if I search for www.google.com, your browser does not know what google.com is. Okay, it doesn't care what this domain name is. So this is the domain name for the website. But google.com has a server somewhere. Okay, somewhere around the world, it has a public server with a public IP. Okay, and on that IP only, the public IP, this browser needs to connect to. Okay, but how does it know what that IP is? So firstly, whenever you type this domain name, this request is sent to the ISP, Internet Service Provider. In the Internet Service Provider, they have a DNS record. So they'll have DNS servers where in that DNS server, they have records saying that so-and-so domain name is connected to so-and-so websites. So if this is the domain name, this has this IP. If this is the domain name, it has this IP. So each domain name is linked to its exact public IP. Okay, so that is known as a DNS host record, 1.2.3.4 or something. Okay, so your DNS server does a job of linking the IP address to the exact domain name, because over the internet, whenever you want to connect to something, you always connect on the public IPs. Okay, but since we can't remember these IP addresses and all, we have a name assigned for it. Okay, and that linking of that name to that IP is done with the DNS server. So it links or translates a domain name to the IP address and vice versa. So when I'm connecting to www.google.com internally, it is going to a public IP. Okay, if you want to check what that public IP is, you can open up your command prompt and search for ping www.google.com. Sometimes it gives you IPv4 address, sometimes IPv6, depending on your ISP. Okay, I'm getting IPv6 at the moment. Ignore this. If you want the IPv4, there's a website called DNS Dumpster. This website I need to show you in the information gathering class, but let's skip ahead a bit. Okay, so if you want to find the exact public IP for any website, you can just give the domain name over here and click on search, and this shows the exact IP for that website. So in host record, scroll down for google.com, you can see the IP is 142.250.148.139. If I copy that IP and if I go to the browser and if I paste it over here and if I hit enter, you can see this is still loading google.com. Okay, so this is the exact physical address of the device. Okay, this is like the home address. Okay, but since not everyone can remember that long home address, you have a short address also, like so and so person's house, Mohammed residence, or you have like an apartment name. Okay, not everyone might know that apartment name, but linking that apartment name to the exact door number is what does the job of like a DNS server, like the postman. Okay, so your DNS server does the job of a postman, linking that exact domain public IP to the domain name. Okay, so whether you enter the IP address or the domain name, you should get redirected to the same website. And that is happening because of the DNS server. Is this clear, guys? Any questions or confusion, or do you want me to repeat something?
Sir, we can use IPv6 IP.
No. IPv6 don't get redirected like that. Okay, so if I copy the IPv6 address and if I paste it, so if I copy this, let me show you. If I right click and copy this, and if I paste it in the browser, it won't give you the access. As you can see, I'm not getting that page.
Why, sir?
Because of a concept called tunneling. So you need to perform something called as tunneling on your router to access the IPv6 address. Okay, since defaultly tunneling is not done, you can't access that IP just like you access IPv4. Okay, so that is why it doesn't work. Okay. Any other questions, guys? Any other doubts, or do you want me to repeat something? Anything which I've not understood? Is this clear, guys? These concepts are very important for our further classes. So please do not hesitate to ask questions or ask me to repeat something. Okay. Okay, perfect. So one last concept that I want to discuss for today's class is special IPs. Okay. We have already discussed CIDR value. Okay. We'll discuss about special IPs now. So in your whole IPv4 range, there are two special IPs. One is known as a PIPA and the other one is known as Loopback. So you might have seen this IP a lot of times, 127.0.0.0 to 127.255.255.255. This whole range of IPs is known as the Loopback IP. And the main purpose of this IP is only one thing, to check if your NIC card is functioning properly or not. Now, what is this NIC card? So if you just open up your browser and search for NIC card, NIC stands for Network Information, Interface Card. Okay. Now, if I just open up an image, let me show you. This is how your NIC card looks like. Okay. So in your laptop or in your computer, you'll have a chip like this. And this chip is primarily responsible for all the network connections. So whenever you connect an Ethernet port, as you can see, it has the Ethernet port. This is the Wi-Fi chipset and all. Okay. So this card is the main card which is responsible for giving all the network interface connections. Okay. If this chip malfunctions, if this chip burns up or just gets destroyed or whatever, you will not be able to get an IP to your system. You will not be able to see the interfaces. The interfaces won't get detected. Okay. So just to check if this card is functioning properly or not, you have the loopback IP. Loopback in the sense is nothing but you try to ping your own IP. You try to loop back to your own IP and check if it is replying back or not. How do you do that? Just go to the command prompt and give the command ping space any IP 127.0.0.1. And if you get a reply like this continuously, it means that the NIC card is functioning properly. Okay, so you'll get 3 replies and after that it will stop for a while. Okay, so again, you can give any IP in the whole range. Ping space 127, 127, 255 or 254, any random IP, chalega. Okay, you can ping any IP in the whole range. Okay, so if you were to ask me back then, this was a huge wastage of IPs. So the whole network was wasted only for one single purpose, to check if the NIC card is functioning properly or not. Second IP, a PIPA. A PIPA stands for Automatic Private IP Assignment. And this ranges from 169.254.0.0 to 169.254.255.255. Now, as the name, excuse me, as the name itself suggests, automatic private IP assignment, which means if your device is not getting an IP from the router, from a DHCP server, or from manually methods also. So if you're not assigning an IP manually or automatically, then your operating system itself, your Windows or Linux or whatever operating system you're using, that itself will assign an IP address. And that is what is meant by automatic private IP assignment. So your operating system will automatically assign a private IP to your device when it can't get it from manual or automatic methods, from the DHCP server or manually from the network admin. Okay, so these are the 2 special IPs, guys, that you have in the IPv4 range. Okay, there's one more small concept called MAC addresses to learn. but this we'll learn in the coming sessions. Okay, what is MAC address in the spoofing of IP and MAC address class. Okay, so nothing further to discuss, guys. There's also something called IPv6. This also I'll be discussing in one of the further classes. So we'll discuss about IPv6 also, how this is different and what is the range of IPv6 and all that. Okay, in that case, system is connected to the internet. Madhusudan, I didn't get your question. What is that? Which case system is connected to the internet? It's not, Madhusudan. As I've mentioned, these are special IPs. So 127 also, this is my local IP only. PIPA IPs also, these are not public IPs. Okay, to be connected to the internet, it needs to be a public IP. These special IP addresses are not public IPs, guys. These are private IPs only. Okay, but some special scenarios. Okay, is that clear, Madhusudan? Please do not assume that the special IPs are public IPs. They are private IPs only. They are assigned to your system in some certain special cases. Right. Okay. Any other questions, guys, for anyone else? Any other questions or doubts? Does anyone want me to repeat anything? Because we still have 10 minutes left. If not, we can exit the session. If so, please let me know. Again, guys, one last quick reminder. Please let me, please, if you're from the institute, if you're my contact, let me know if you have done the payment or not. If you're from the institute's reference, please make the payment to the institute. Okay, because from Monday, the link will be changing and I'll be sending the updated link to all the payment, to all the people who have successfully made the payments. Okay, so yeah, any questions or doubts?
So we can hide a public IP2 in the internet.
Sorry, I didn't get your question, Irshad.
When we get the internet, we get my private IP now, sir, from our instrument device.
Yeah, from your router, you will be getting your private IP.
While surfing, we use a private public IP while surfing on the